In the last presentation, we looked at the nature of systems. In this presentation, we're going to look briefly at the life cycle of a system, before, of course, we focus on the main interest in the course, systems engineering. As with almost anything else, a system has a life. At some point, it doesn't exist. It's brought into being, it's used, and then it's disposed of, once we can no longer use it for the purpose for which it's created. Throughout the life of a system, therefore, there are a number of phases and activities, each of which builds on the results of the preceding phase or activity. Now, the sum of all these phases and activities is called a system life cycle, which can be described in a model that has four very broad phases. It starts with the conceptualization of the business needs for the system in the pre-acquisition phase. The system is then fine-tuned and formalized and is realized in the acquisition phase. It's then used and evolved in the utilization phase, and is finally disposed of in the retirement phase. Let's look at each of those phases in a little bit more detail. The life cycle begins with the pre-acquisition phase, with an idea for the system being generated as a result of business planning. The early needs of the business are confirmed, and they're supported by a business case, which justifies expenditure of organisational resources on the acquisition of the system. In some instances, the pre-acquisition phase may determine that it might not be feasible or cost-effective to proceed to acquisition, for example due to technology limitations or funding shortfalls. In that sense then, the pre-acquisition phase is where the organisation spends research and development funds to ensure that only feasible, cost-effective projects are taken forward to acquisition. Once the business needs for the system can be justified, they provide the input to the acquisition phase, which is focused on bringing the system into being and into service in the organisation. This would normally involve defining the system in terms of three major artefacts, which we'll describe shortly: business requirements, stakeholder requirements, and system requirements. We'll also see shortly that the customer could then go on to develop the system, but most commonly a contractor is engaged to develop the system and then deliver it back to the customer, who introduces it into service in the utilisation phase. The system is operated during the utilisation phase, during which time it's also supported by the organisation that owns it. During utilisation, the system may also undergo a number of modifications and upgrades of different sorts to rectify performance shortfalls, perhaps to meet a changing operational requirement, or perhaps because the external environment has changed in some way, or perhaps even that the ongoing support of the system has become expensive and needs to be modified to ease its maintenance. Now, the system remains in service during the utilisation phase, perhaps being modified over time, until the business has no further need for the system, or it no longer can do what the organisation requires of it, or it does but it's not cost effective to keep it in service. The system life cycle therefore concludes with the retirement phase. If the business need for the capability still exists, the conclusion of this life cycle at the retirement phase will most likely also mark the start of another life cycle for the replacement system, and the process begins again. Throughout the system life cycle, there are a number of parties involved. First, of course, there's the customer organisation. They're managed by enterprise management, who set the direction for the organisation, and pass the tasks to business management, who are responsible for the activities that are conducted by the operations element of the organisation, run by the operators, and sometimes called the users. The systems used within the organisation are acquired by an acquisition element, also called the acquirer, or in some standards the tasking activity. They belong to the organisation and they work under the auspices of a project manager who runs a project. Project managers are also supported by a number of other related disciplines. One, of course, the reason why we're here, is system engineering, but there's also requirements engineering and other specialty engineering disciplines, quality assurance and integrated logistics support. The operators who do the business in the organisation are supported in their operation by the support element, which supports, sustains and maintains the system throughout its life. In addition to operational, acquisition and support staff, there are many others in the organisation who also have a stake in the successful implementation of the project. These people we call stakeholders, and they include representatives from management, financial, operations, supply, maintenance and facilities areas of the organisation. The system is, as I said before, most likely obtained from a supplier, also called in some standards the performing activity, who may deliver the system off the shelf or may develop it, in which case they then also call the developer. The supplier, or the developer, may be an internal part of the customer or the acquirer organisation. If the development of the system is to be undertaken in-house, the acquisition element of the organisation, the acquirer, will engage with the development organisation, the developer, in order to support the system. But it's increasingly common these days for the supply or the development to be undertaken outside by a contractor, which is therefore the entity responsible for supplying and most likely for designing and developing the system to meet the customer requirements. And so most commonly these days we have customers and contractors. The relationship between the customer and contractor varies with each sort of project, but for each project, the relationship is defined by the terms and conditions of a contract between the two parties. In many cases, the contractor themselves are not able to perform all the work and devolves the packages of work into a number of subcontracts delivered by subcontractors. The terms and conditions relating to this work are then in the relevant subcontract. Responsibility for the various phases of the system lifecycle is spread across the enterprise or the organisation within which the eventual system will operate. The initial pre-acquisition phase is clearly the responsible of enterprise management, who conduct the early business planning and establish the business case for the projects that are required to support the organisation. Their work's not over though. They must stay engaged with the system development process throughout acquisition, utilisation and retirement. The system is ultimately the responsibility of business management, more than anyone else involved. It is, after all, their business. A project is then established with a project charter, providing authority from business management to a project manager to expend organisational resources on acquiring the system. The project manager will be principally responsible for the acquisition and may be engaged for the other life cycle phases as well. Working for the project manager is systems engineering. Now, system engineering is an important discipline responsible to the project manager to perform the technical management for the project throughout acquisition and utilisation, as well as retirement. Now, of course, once the acquisition is complete, the system is introduced into service and is operated by the users and supported by the support element. These people have been involved earlier in the acquisition phase. They provided essential input to the system engineering and the project management processes, but now they're principally responsible. They, like all parties involved, are involved in all phases of the life cycle, but the roles and responsibilities for each party shifts in emphasis between those phases. If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.